Okay, let's start. Good evening. Am I audible?
Yes, audible.
So today we will discuss some questions related to the week 7 content, which will contain some questions from the lump mass system as well as the continuous mass system. So 6 to 7 problems we will solve according to time. So let's start. And in the uh, you posted that question on the Google form, so the that will be updated soon. Your answer range, okay?
Yes, sir. Yes, sir.
So that
Thank you.
was your A and B was correct, but C was wrong. So only for A and B the answer range will be updated.
Okay, okay. C is wrong, sir.
C, because yeah, if you see in the like the answer that was around 270 100, but your answer around some 470 or 450. So how that range can be that much?
No, no, no. But actual answer I'm asking. Okay, it is only around 270 to
Yes,
80, right?
yes, yes.
Okay, okay. If you consider mass of the column and mass of the tank also.
Yeah, how much like difference is coming into the bending stress? Did you consider the for the calculating the bending stress outside diameter, because that given for you inside and outside diameter to finding out the bending stress. So when you
Okay,
calculate the section modulus, so for
okay.
calculating section modulus, you will be need I divided by y. So y
Yes,
is
yes,
the distance of the extreme fiber. So your
yes.
extreme fiber distance would be, what was the external diameter? Some 168 something was there.
Outside diameter by 2.
Yes, outside diameter by two, whatever it was. So that you need to do, I think.
Yes, yes.
So you
I
do
did.
that, or either is different thing.
Okay, I did same things. Okay, okay, we can check,
So
sir.
you can check in the solutions if you find
Okay,
anything else. So we can discuss them.
okay, sir.
Is my screen is visible?
Yes, sir, visible.
Okay. So now the we have to start the uh, problem with the uh, we have a number of degree of freedom, but including that we need to convert into a equivalent single degree of freedom system by using the continuous mass system or the like the lumped mass system. So in that question, so that it is called a generalized single degree of freedom system or whatever. So this question, here you can solve easily. Like we need to create the equation of motion for the system. So this equation, like in this there can be multiple degree of freedom, but we can represent all them into the 1 degree of freedom. So that's how we can say it is a 1 degree of freedom system. So we need to like generate a equation, develop a equation for this system. If let us suppose I am applying a pt mass at that point. So how my equation would look like. So you can solve this equation by assuming some safe function, or you can solve this equation by the equilibrium of the forces, which we used in the earlier cases. So here also we will use the equilibrium, because in that course only the equilibrium part has been considered. So that's why we will use that only that part. Okay, so let us go one by one. Okay, if I will apply, if we are applying a pt, so means my bar is rigid, it will go upper side. Okay, with an angle, let us suppose that would be a theta, whatever you want you can consider. Okay, and then my that box will also go like that. Okay, so and along with that theta, my box is, how my box, it is initially that was like that, but when I'm giving a theta rotation, it is coming like that. straight. So that my box is also try to rotate, but it resisted because it is a rigid, so it will not rotate. So that force will generate rotation also in this box itself, also in this mass. So we have two inertia. One is for this rod, which is I, we know. One is for this mass, which is M. So due to this transverse displacement in the vertical direction, we have some M, some whatever the displacement we will got, that will be the some quantity time double dot. That is the one thing. Another is the rotational of this rotational moment of inertia of this plate. So rotational for the any plate which has the size of, let us suppose we have the size of, this is a B, this is a D. So rotational, how, what is given as a I is equal to, can anyone tell me what is the I for the rotational about the center?
M d square b square.
Yes, MB square D square divided by 12. Okay,
Yes.
so that is given for that. So now we first we need to find out that what are those inertial for the all the like road and the that rotational and for the transfer vertical transfers of the mass. So first let us write about the, if my rod is rotate about the hinge, this is hinge O. So what will be the my I for the bar? Anyone?
ML square by 12.
No, ml square 12 is about the center.
Okay, okay. That is 3
So for
ml,
this,
ml square by 9, right?
no, no, no. Let me write. So that is the ml square by 12 about the center, and I need about the edge. So what is the center to this
12
distance
by
L
2.
by 2? So that is
Yes.
m into L by 2 minus 0 square. If I
Okay.
solve this, I'm getting ml square by
By
3.
3. Right, right.
So one is that, and how much rotation of that my like how much displacement of the mass about the center. So this is the distance is L by 2, like let us suppose I'm writing here. So this is a distance of L, okay, plus my bar mass is attached here. So up to center, what is the distance? That is L by 8. You can see into the figure. So L by 8. So how much total distance for this? That will be L by L plus L by 8. How much it would be? 9 L by 8. Okay. So when I giving the rotation about this, so this center to this center, how much this one? About theta. So that would be the I of plate, I can ask that. So that would be the M into 9L by 8 into theta double dot. Is it okay? Not theta, like theta double dot will come later. Like that will be the like in total force,
Yes.
not the only inertia. Total force. Okay, and for the bar it would be like I bar we have calculated. So Fi bar is ml square by 3 into theta double dot. Okay, now there is a rotational about that. So rotational, we know for the rotational of the bar plate rotational, so that is we have discussed as m b square plus d square divided by 12. And here I have given b is equal to L by 8, d is equal to L by 8. So can you give me the value of I plate? Can you give me the I plate? If I will put m into L square by 8 square plus L is not 8, it would be L by 4. It is given as a b is equal to L by 4 and d is equal to L by 4 because the center is given at L by 8. So that will become m into L square by 16, L square by 16 divided by 12. So how much I am getting? So I am getting ml square by 96. Okay. So for this, the f of plate about theta, that would be the how much, ml square by 96 into how much that rotation is the theta, because the rotation would be the same. So that would be the theta double dot. Now the force it about the this at the center. So if I will like applying forces pt here, so there is a resisting force downward, fs. Okay, and pt is there. So how much fs would be k time my displacement, how much displacement theta, with this L by 2 into theta. L by 2 into theta is my displacement for the force. Okay, anything else? Nothing. So now I am like applying those things at a point. Damping force is also there, so that is the c damping is rotational. So fd is here directly, c into theta dot. So I can directly like write my forces. So when I apply this rotation, so what are my forces are applied at here? fd, fd, and these are calculated corresponding to these f plate ml square by this one and this one. So that is f I bar, f plate of in the theta direction, f plate in the transfer direction. Okay, and then we have the applied forces, ks, fs. Okay, and pt is in the this direction. So that is a pt. So if I take moment about the hinge o, so what is that? That is the f I bar plus f I plate in the rotational plus f I, no sorry, plate in transverse and plus fs into L by 2 and minus pt into it is applied at the center here. So that is how much that distance we have calculated, that is the 9 L by 8. That is pt into 9 L by 8 is equal to 0. Okay, so what I need to do, I need to only put those value. So fi bar, what is my fi bar? Ml square by 3. So that is ml square by 3 into theta double dot. Fp rotational ml square by 96 into theta double dot. Fp transverse, Fp transverse is this one, ml square by 3 again. That is uh, transverse is this one. Wait, 96. That is m into 9 L by 8 theta double dot plus fs is the k into L by 2 into L by 2, and that is a pt into 9 L by 8. So can you solve it? Can you give me the final equation? Like adding these terms for the theta double dot. This is the simple like kl square by 4. This is p into 9 L by 8. Can you give me the what is that inertial equation plus theta double dot into this? Anyone?
There, the third term m into 9l by 8 theta double dot, right?
Yes,
There, the first three terms have l square terms, and the third term we have only l term. Think
that
we,
would be multiply 9L by 8. Okay.
yes, yes.
So did you get it? How much?
Actually, I got from digital form like 1.6 ml square theta double dot.
1.06. Okay, let me
1.60.
1.60. Let me check. Yeah, that is okay. So I am getting in the form of 103 by 64 ml square. So this is your final equation. So this kind of problem you have in your assignment also. So this way you can solve this. Okay.
Okay.
Now we have a question in which we have considered the mass as well as like a frame is shown in the figure which we need to determine the time period, like we need to determine the time period of the system by assuming my girder is it is a very rigid mass which is given, and the deflected shape of the column to be due to the lateral force p acting on the, so the shape function is not given us, the deflected shape is given in term of the ux, like that is a ux is given as a p over 12 ei into 3l square x minus x cube. Okay, so from this we can calculate the shape function. Okay, so first we need to find out the time period, and then we need to determine like how much fraction is this of the total weight is used to calculate the time period if we consider it as a zero. So that part b we discuss later. First part a. So can you tell me how do I determine the shape function? Anyone? What is a shape function? It is a, can
It
you
is
tell me?
a assumed deflected shape.
No, no, assuming deflected shape is it okay? Like, so shape function is what? What it is show the variation within the element, within the frame, from the with respect to the nodal coordinates. If you read the shape function in the FEM or somewhere else, so what we know as the shape function, like if we have the two nodes and we know the deformation, we know the value of deflection at this one u unknowns, so if we can find out the value of unknown u within the element with respect to these nodal coordinates. Did you get it?
Y- Yes, yes.
So that we call as a shape function. So here we have given the like
Can you tell me like what exactly we can define a shape function technically?
technically it is like that only, like it is a variation, it is a like it shows the variation within the element with respect to the nodal variables or nodal unknown within the element. Main term in this is the within the element and nothing
Okay.
else.
Okay.
So here, how can I calculate the shape function? Like I know the ux. So can you tell me how can I calculate shape function? So ux is given to me if I divided shape function. Is there shape function has any unit?
No, no.
So if the shape function has not any unit, so that we how we can calculate like that? So ux is given and we have to divide it by the maximum displacement at the top. Maximum maximum of u. So maximum of u, how much, at which point that x is equal to l. So 8x is equal to l. What is my u? Ux would be u max. Okay. So 8u is equal to l. If I put 12 ei into 3l square into l minus l cube. So how much it is coming? It is coming out to be pl cube over 6ei. Okay, so I can calculate my shape function as a psi x is equal to p over 12 ei into 3l square x minus x cube divide by pl cube over 6ei. Okay, so that ei will be cancel out, p will be cancel out, so that will be become as a, and 6 also will be cancel out, so that will become 2, so that becomes as a 3l square x minus x cube by 2, or I can further simplify it as a psi x is equal to 3 by 2. Yes, is there something l cube is also there. Okay, so that is the 3 by 2 into x by l minus 1 by 2, 1 by 2 into x by l cube. Is it okay?
Yes.
So in the like here we have considered the mass per unit length of the column. So the mass per unit length of the column is m bar. Okay, so it is in how kind, kilogram per meter. We can write it like that. Unit is not given, but that is meaning like that. So can you tell me how, what is the m equivalent? It is the m bar times shape function into dx will give me the total mass of the column. Is it okay?
Yes. Okay.
So I have the two columns. Okay, so both the columns has the mass though, so m bar would become as a 2m. So m equivalent would be 0 to l 2m bar into 3 by 2 over x by l minus 1 by 2 x by l cube square dx. So can you solve this for me to find out the m equivalent? Give a try to find out M equivalent. Can you tell me? Did you get the final answer?
It is 2.5 ml.
No, it is coming out to be M equivalent as a 0.9714 M bar L. It is coming like that. Okay, might be you are getting some some calculation mistake. So M equivalent is this. Now we need to find out the K equivalent. So what is the K equivalent? So to find out the K equivalent, what is that? That is 0 to L EI into double derivative of the shape function times square into dx. Okay, so here we have the two columns, so that would be become as a 2ei. Okay, and let's do the double differentiation of the, so shape function is that 3 by 2 x by l minus 1 by 2 x by l cube. So if you do this for the first derivative, it will be coming out to be 3 by 12, and for this term, it will be coming out to be 3x 3x by l square. Okay, no, I think it is wrong. So that would be 3x square over l cube. So if you do the double derivative of this will be coming out to be 0, and this will coming out to be 1 by 2 into 3 into 2x over l cube. So that will be cancelled out. So that becomes as a minus 3x over l cube. Okay. So now K equivalent, I can find out 0 to L. As for the two columns, that will be the 2 EI. Okay. Double derivative of 3x over L cube times square into dx. Can you calculate me this? Because this is a easy rather than the previous one.
It is 6 A by L cube.
Okay. So it is coming out to be 6 EI by L cube. And this is also, we know that for the column which is like hinge at the bottom, for the one column it is 3 I by L. Okay, for the both the columns it would be 6 EI by L. So now you have the K equivalent. So now what is my total mass? So I have the rigid mass at the top M1, which is the 4 m bar L. So that is the M1 plus M equivalent, which I have calculated for the both the columns. So that would become as a 4 m bar L plus M equivalent, how much? That is the 0.9714 m bar L. So that becomes as a 4.97 m bar L. So now I can calculate the time period Tn. So that would be the 2 pi k by m or m by k. M by k, I think. M by k. So 2 pi m is how much? 4.97 m bar L over 6 EI by L cube. So you can simplify it in the terms of, when you simplified it, how much you are getting. So my time period is coming out to be 5.72 L square into m bar over EI. So this is my time period of the system. Okay. Now in the part B,
Uh, when you calculate the omega n,
yes,
uh, actually the we have derived in the lectures like a root of uh, m equivalent by k equivalent, right?
yes, yes.
Here you are using total mass.
Actually, that like M equivalent is okay, but we need to consider that rigid mass as well also, no? In
Okay.
the lecture, you are considering only, like, let us suppose you are taking a cantilever, okay, and then what is, there is some mass is given to you, okay, and then you calculate the, then some section property EA is given to you. So what you are calculating, M equivalent, K equivalent, and directly you are calculating frequency K equivalent by M equivalent. Is it okay? Is it that you are doing?
Yes, yes.
But here, if let us suppose we have given a lumped mass as well at the top, then how would you deal with that? You need to M equivalent plus this mass would also be playing the picture.
Okay.
Okay, so this is,
Okay.
the, this way you need to do that. So this is the Tn. So in the second part, what is they ask? They ask, like, what is a fraction of the total column weight assumed for the lump with the girder weight will have the same period. So it is asking, like, what fraction of the total weight. So total weight of the mass, how much? So for the one for the one column, that is a m mass, is the m mass per length. So for the one column it is m bar into L. So for the two columns, total mass is the 2 m bar L. Okay. So it is asking how much fraction of that mass, the total mass, is used so that my time period will be coming out to be same. Did you understand the question? Anyone? It is asked,
I didn't understand.
it is asking in this question, like, what is the percentage of the total weight or the mass is considered, we should consider that whatever the time period we calculated with using this procedure, which is 5.72 L square, this should be same, like that. This is the time period, one time period. Another time period is, how do I calculate, like that, like, time period is calculated at 2 pi, k would be the same, K equivalent. Okay. So in the mass, One is the mass 4 m bar L, equivalent mass, and how much percentage of the total mass, which is mt, or mt we have right how much that was 2 m bar L. Okay, so that is, we can write it as a 4 m bar L plus alpha is the percentage, like let us suppose it is a fraction of the mass, is the 2 m bar L. Okay, so that my time period should be equal to whatever this time period, 5.72 L square m bar L. Yeah. Did you get it?
Yes, yes.
So in this you can solve these two equations directly, or either, as we know how much this mass, like total mass is, what was that, 4 m bar L plus that was the 0.9714 m bar L is that, and in the against how much that is, 4 m bar L plus alpha into 2 m bar L. Okay, so that will be cancel out, so your alpha would be 0.9714 m bar L divided by the 2 m bar L. So if you calculate it, it is coming out to be 0.485. So it is coming out to be 48% we consider, we need to consider to calculate the time period in the, it will be coming out to the same time period as we calculate, consider total percentage of the mass as a 48%. Did you get it?
Yes, yes.
Okay. So if you have any doubt in this question, you can ask. Otherwise, we are moving to the next question. This is, I think, very simple question. This you can do it, like you have given the shape function. Like though, like the previous question was for the continuous mass system. For the second question, this is the lumped mass system. Okay, so you have given the each story stiffness as a k. Okay, so like it is not like the, like k, like whole story stiffness is given k, including both the columns. So you have the story stiffness from k1, k2, k3, k4, k5 is given to you k, and mass is also for the all the lumped mass m1, m2, m3, m4, m5 equal to m. Okay, so you have given the deflected shape also. So it is my first story 1, 2, 3, 4, 5. So the shape function is giving me as a 1 by 5, 2 by 5, 3 by 5, 4 by 5, and 5 by 5, or 1 by 1. I can write 1. So this is the shape function. Okay. So can you tell me the generalized mass for the lumped mass system, or the discrete system we called it as a. How do I calculate the M equivalent? Anyone?
That is mj into 5j square.
Okay. So that will be coming out to be M generalized as a summation of from I equal to 1 to N, which is 5. Okay, of mi, you are using mj. Okay, I'm using I, so nothing for the confusion. Okay, that is the same, only the notation is a little bit different. So mi or the mj into psi square. So can you give me the m equivalent? Please try and give me the m equivalent.
It is 2.2 m.
Yes, it is coming like that. So how do we do that? So that is mi. So for mi is the m1 into phi 1 square, m2 phi 2 square, m3 phi 3 square, m4 phi 4 square, m5 phi 5 square. Okay, so that is coming out to be, so m1, all the m's are same, so I'm taking m outside, so that will become as a 1 by 5 square, 2 by 5 square, 3 by 5 square, 4 by 5 square, and 1 square. Okay, if I do that, as you have said, I'm getting 11 by 5 m, or 2.2 m. Okay, similarly, can I find out the k stiffness? So that is find out as a summation of I is equal to 1 to n into ki into psi I minus I minus 1 square. So can you do that? So for this, let us simplify. K1 into phi 1 minus phi 0 square, K2 into phi 2 minus phi 1 square, K3 into phi 3 minus phi 2 square, K4 into phi 4 minus phi 3 square, K5 into phi 5 minus phi 4 square. Okay, so that 5 means the zero shape function. So that would, that as the k1, k2, k3, k4 are same, so I'm taking it to the outside. So pi 1 is how much? Pi 1 is the 1 by 5. So that is the 1 by 5 is minus 0 square. That is 2 by 5 minus 1 by 5 square. That is 3 by 5 minus 2 by 5 square. That is 4 by 5 minus 3 by 5 square. Yes, that is 5 by 5 minus 4 by 5 square. Can you give me the answer? Equivalent?
It is k by 5.
Yes. So it is coming out to be k by 5. So what I do need to, we need to find out the natural frequency in this question. That is omega n is equal to k equivalent by m equivalent. So k equivalent is given as a k by 5, m equivalent is given as a 11.5 into m. So that becomes as a k by 11 m. So k is given to you how much? That is given to you 100 kilonewton, or around 1 lakh newton per meter, and the m is given to you as a 500 kg. Okay, so the omega m is coming out to be 4.26 radian per second. Okay, is there any doubt in this question? Any doubt? Anyone? If not, let us move to the next question. So in this question, we have a like same kind of question is there, but in that your assignment, I think that the EI is same for all the parts. Okay, what are all the stories. Here we have the different EI. So three-story shear frame in the structural steel, which E has given to as a 200,000 MPa are shown, and the mass is given as a 50,000 kg. I is given as a 60,000 centimeter power 4, and the damping is the 5% for the all the modes, assuming that the safe function is given by the deflection due to the lateral force that are equal to the floor weight. So we need to determine the floor displacement, story shear, overturning moment at the floor and the base due to the ground motion characterized by the design spectrum of the scale to a peak ground acceleration of the 0.25. So in this question, main thing is to determine the shape function, first part. So we have a three-story building. We have the EI for both the columns. We have the mass for the all three stories. So we can find out the what is the safe function. So for the safe function, it is given as a hint. Assume the safe function is given by the deflection due to the lateral force that are equal to the floor weight. Means lateral force means the shear force. So lateral force is whatever the generated by m by 2 into z, m into z, m into z, like the floor weight. So whatever the shear developed due to this, like these are the forces are applied at here, like m by 2 into z, then mg. These are the forces are applied. So due to this, we need to find out the shear force, and then we can find out the another parameters that would be not take much time. Okay, did you understand the question?
Yes.
Okay, so now let us move to first to find out the shape function. Okay, so for this, what do I need? First find out the story stiffnesses. Okay, so this is the one, this is a two, this is a three. Okay, so first find out, let us suppose k3. So k3 how much stiffness, that will be the 2 into 12 ei by l cube. So here ei would be the ei by 3. Okay, so if I will put ei as a ei by 3, so that will become as a 2 into 12 by l cube into ei by 3. So that will cancel out the 4, so that becomes as a 8 ei by l cube. Okay, now come to the k2 for the second story. So in this it will become as a 2 into 12 ei. In place of the ei, here we have the given ei as a 2 ei by 3. Okay, so if we solve this, I am getting it as a 16 ei by l cube. Come to the k1. So in the k1 it will be a 12 ei by l cube. So that comes out to be 24 ei by l cube. So let us suppose for the simplification I am writing 8 ei by l cube as a k. So I can write it as a 2k. I can write it as a 3k. Okay, and k I can, where the k is 8 ei by l cube. So I can find out as well as k. 8 into e is given as a mpa into 10 raised to power 6. I is how much, is the 60,000 into 10 raised to power minus 8. Okay, divide by how much length is the 4 cube. Okay, so that is coming out to be somehow 15 into 10 raised to power 6 Newton meter. Is it okay? Up to this point, is any doubt? This is a simple calculation. So now we need to find out the shape function. Shape function. So for this, Let me write a story number, story number, story shear, story drift, then the deflection, then the shape function. Okay. So story number 3, 2, 1. Okay. So what is the force apply? Let me write it here. Here it is applying W by 2, it is applying W, it is applying W. Is it okay? So can you tell me what is the shear in the first story, third story? So that shear force in the first story would be the W by 2, third story. Shear force in the second story, that would be the W by 2 plus W. So that becomes as a 3 by 2 W. And the third story, it will become as a W by 2 plus W 5 by 2 W. Okay, 5 W by 2. It is a shear force. So how much drift is coming out to be in this? So this is a K, 2K, 3K, we know. So in the particular story, how much drift? That is the V divided by the stiffness. So that is the W by 2 divided by the K. That is the 3W by 2 divided by the 2K. That is the 5W by 2 divided by the 3K. Is it okay? It is 5W by 2 divided by the 3K. So it is a drift. So you can find out the deflection, like the what will be my total deflection. Like I have the local drift of the each story drift. Okay. So the deflection of the first story is how much? That is the same because the ground is 0. So that is how much? That will be the same 5W by. So that is the same 5W by 6K. For this, it would be the 3W by 4K plus that 5W by 6K. For the third one, it is a W by 2K plus whatever this 3W by 4K plus 5W by 6K. Any doubt up to this? Anyone?
Actually, what can you define this drift? Actually, drift means the if you have two levels, drift means it's a difference between one
Yes,
level to another
yes,
level,
yes,
right?
yes, yes,
Then here you are directly writing uh, story shear by stiffness.
yes. So I am considering the stiffness for particular that level, that particular floor. Like I have force generated in this. How much shear force? I know the stiffness of this, so I can find out the how much deflection in this. Is it okay?
Okay,
In this shear I know, and the stiffness in this system I know, so I can find out the particular deflection for this.
okay,
Similarly for this, so these are the drift only for the story local drift. So to find out the deflection, so this is the first. For this, how much it will start from this to this. Okay, and for the third one, it will start from this.
okay, okay. Understand.
Okay,
Okay,
so this way you can understand, like this is like initially this is a like delta 3, delta 2, delta 1. So it will be delta 1, so that will be the delta 1, so that is the delta 2, delta 3. Okay, so if I'm adding that, That will coming out to be 25W by 12K. That is coming out to be 19W by 12K. And if I will multiply it up upper and lower with the 10 2, so it will become 10W by, so it will become as a 12K. So now I can find out. So this is the maximum deflection, 25 by 25W by K. So it would be the, in this, how much the phi is the 25W by 12K is the U, and I need to divide it by the maximum deflection. The maximum deflection is how much? That is the same. So that is divided by the also 25W by the 12K. So that is coming out to be 1. For this one, in this I need to 19W by 12K divide by the 25W by 12K. In this 10W by 12K divided the 25W by 12K. So when I simplify this, I am getting a safe function as a, so for this I am getting 2 by 5. For this I am getting 19 by 25, and for this it is I am getting 1. That is 1, that is 19 by 25, that is 2 by 5. Okay, is it okay? Up to this, any doubt?
Actually, this uh, in the lecture also I didn't find here how this shape function is finding like this. Can you please explain? Because I didn't see anywhere in the lecture uh, deflection by maximum deflection, right?
Yes.
It's how it is like a shape. You are equating the shape function. You are finding. Okay, okay. I understood. I understood. Okay.
Initially, in the first question, I told you the safe function. Like in the second question, safe function is what? Un
Yeah.
divided the maximum u. So,
Yes.
so here, like I have the at the different three levels. I have delta 3, whatever, let us say delta 2, delta
Okay.
1.
That means you can say like it is like a reference.
Yes,
We are converting whole system as a
shape function.
one. Oh yes. Yes. Yes.
Normalizing with the maximum. You can say like that.
Yes. Yes. Understand.
Okay, so now you has the phi, because in the previous question also you can see these are also the normalized values are given to us.
Yes. Yes.
So after getting phi x, you need to find out the generalized mass, generalized stiffness, or the K equivalent. Okay, and there is a, in the, because here we have the ground excitation UG, so there is a one factor if you go through the lectures, L, load excitation factor. Okay, so first find out the M equivalent. So that is the same mi psi I square. Okay, so mi is what? M by 2, m by 2 into 2 by 5 square plus m into 19 by 25 square plus m into 1 square. So if you solve this, wait, I have done something very dangerous thing here. So for the first story it was m, second it was m, third it was m by 2. Okay, so can you give me how much you are getting generalized mass? So we are getting it as a 1.2376 m. Is it okay? Similarly, you can find out the K equivalent. So that is also Ki time psi I minus psi I minus 1 square. Okay. So for this, for the first story, what is the stiffness? 3K. So that will 3K into 2 by 5 minus 0 square. For the second, it is a 2K. So that would be the 19 by 25 minus 2 by 5. For the third, it is a K, which one is the 1 minus 19 by 25. Okay, square, square. So if you solve this, you will be getting this like 0.7968K. And there is a load excitation factor generalized, which is given as a m mi psi I. Okay, so that would be the m into 2 by 5 plus m into 19 by 25 m by 2 into 1. So if you solve this, you will get this 1.66 m. Okay. So can you give me the natural frequency and the time period so that we can find out the SA by G, and using that we can find out the our response quantities. Find out the omega and Tm. And you have the where the m is given to you as a 50,000 kg, stiffness K, like we have represented, that was the 15 into 10 raised to power 6 Newton per meter. So give a try.
Omega n is 9.479.
Mhm. It is wrong. So omega n is the K by m. So how much K is the 0.7968 into 15 into 10 raised to power 6, and how much m? M is your 1.2376 276 into 50,000. So let me calculate how much we are getting. 0.7968 into 15 into 10 raised to power 6, 1.2376 into 50,000. So that is coming out to be 13.89. Where do you did you mistake?
Yes, actually, I have taken this load excitation factor
Oh,
instead of M equivalent.
okay,
Okay.
okay. So now using that we can find out the time period 2 pi by omega n. So that would be the 2 pi by 13.89. So it will be coming out to be 1.452 second. So corresponding to 0.452 second, we need to find out what is my SA by G. Okay. So in this graph, if you can see, so corresponding to 0.452. So That 0.452 is lying in this range.
Yes, 2.71.
It is lying in this range, so that will be the 2.71. Okay, so along with that we need to, how much we need to, response is equal to 0.25 g also. It is given in the question, so that is coming out to be 0.675. Okay, so we can calculate acceleration as a is equal to, or we can write it as a is equal to 0.675 into 9.81. So that is coming out to be 6.64 meter per second square. So now using this assay, we can calculate the spectral displacement d, which is a by omega n square. So can you give me that? 6.64 divided by the 13.89 square.
0.034.
That is coming out 0.0344. So it will be coming around 34.4 mm. Okay. So this is the like in terms of the d. So peak displacement, if you go through the notes, your z naught peak displacement is given by this factor gamma multiply with the d. Did you remember?
Yes, yes.
Okay, and that gamma is given by the load factor divided by the m equivalent, okay, into d. So that gamma factor, let we first determine. So the L factor we determine is a 1.66 m bar, and the m equivalent, how much that was? That was 1.23. Okay, so if we will do that, so that will be coming out to be 1.341. Okay, so your z naught is becomes 1.34 into d is 0.0344, so that becomes 0.04619 meter, or we can write it as a 46.2 mm. Okay, so this is our z naught. So that is the peak displacement. So now we need to determine the each quantity. So in this first one is the floor displacement. So can you tell me how do we calculate the floor displacement? Do you remember the formulation for the floor displacement? So the floor displacement is given as a, like how you calculate floor displacement is particularly fj. You can determine k time u naught, and u naught for each floor is given as a shape function psi times the z naught. Okay, and k is known to you as a m omega n square. Okay, and u naught is the psi into z naught. Okay, and how can I write Z naught, and Z naught is given as a m omega n square psi into Z naught is given as a this factor time d. So I can write it as a m omega n square psi gamma d can be written as a by omega n square. So that will cancel out. So my FSI would be m mi psi I gamma into a. Okay.
Actually, we are finding flow displacement, right? We can directly.
Oh, that is the Flores. Sorry, I was doing it as a story seer. This
Yes,
was
yes, yes.
this was a story seer.
Directly, like u0 equal to
Yes,
pi
yes, yes.
into.
That's why I missed that. No, let us find the stories here first. Okay, so this way you can find out the stories here. Similarly, you can find out the story displacement or the floor displacement. So floor displacement is u naught is equal to psi times z naught. Okay, so psi is given to as a 2 by 5, 19 by 25, 1, and z naught is given to as a 46.2 mm. So if you solve this, so your floor displacement are coming 18.5, 35, and 46.2 mm. Is it okay? So now you can find out the storage shear, so that we have discussed earlier. So FSI you can find out mi psi I, this one factor gamma into a. So find out the F1, F2, F3. F1, F2, F3. So for F1 is the M1, it is M1 times psi 1 and this into A. For this M2, psi 2, this into A. M3, psi 3, this time A. So the M1 is what? M. So how much M is the 50,000? Psi 1 is the 2 by 5. That factor is how much that factor? 1.34, not 1.34, yeah, 1.34. And acceleration, how much did we get acceleration? 6.64. Okay, same for M2. The mass is same 50,000, that is 19.25, that is 1.34, 6.64. For M3, that is M by 2 into 19 by 25, 1.34, 6.64. So can you give me this F1, F2, F3?
Their psi function is 1, right, in F3.
Oh, that would be one. So find out F1, F2, F3. So that is I am getting. Did you get it?
Yes, 177.952.
Okay, I am getting 174.6. There is maybe due to some like decimal places. Okay,
Okay. 338,
yes, 338,
444.
and that is the 4, not 444, not divided by 2 also.
Okay, okay.
And that is in the kilonewton. Okay, we divide it by the thousand already.
Yes, yes.
So I can write my forces. F1 is the 222.8 kilonewton, F2 is the 338.6 kilonewton, and F3 as a 174.6 kilonewton. So can I find out the shear and make the shear force diagram? So the shear force diagram.
Uh, can we conclude one thing here? Uh, it's not like increasing or decreasing order. The story here. Can we say any statement from this story here?
No,
Like
this is not the story shear. This is the story forces, not the story shear.
story forces. Okay, that means a story force. Suppose if I want to conclude like based on story forces,
Yes.
can we adjust this mass like these are two triple two, right? The first force is triple two, and second is 338 and 174, right? Is there any requirement like it is if you decrease or increasing order? Is there any statement? Can we say?
No, these are the forces. For the shear we can have, like now we calculate the shear force.
Okay.
So in this, if you calculate the shear force, this one from this diagram. So in this, how much shear force, that would be the 222.8. In this, how much, that would be the 228.8 plus 338.6. And for the third one, it is 228.6, 228.2.8 plus 338.6 plus 174.6. So when you draw this shear force, so this is your 228 kilonewton, this is your 561.5, this is your 736 kilonewton. So now you can ask what, this is a shear force, shear steady force.
Okay, no doubt, no doubt.
Okay, you are confusing, I think, due to the like the un like unnatural thing in the forces, so you are considering this as a shear. That's why I think you were in the doubt.
Yes, yes.
Now after calculating the shear forces, we need to find out the bending moment. Okay, so for the bending moment, you simply, you can find out, like at the base how much bending moment at the base, that would be the f3 time the height is the 3 into 4, f2 into 2 into 4, and f1 into 4. This is the for the base moment. So how much is the f3? That is at 22.8 into 12. F2 is how much? 338.6 into 8, plus f1 is the how much? 174.6 into 3. Not the 3, it is 4. Okay, so if you do that, how much moment I'm getting? I'm getting 60 81 kilonewton meter. Okay. Same if you want to calculate the moment about the top of the bending moment, the first floor. At first floor, let us suppose at this level you have F3, you have F2. So at this level, M1, that would be the F2 time 4, F3 time 8. So F2 is how much? 338.6 into 4, it is 174.6. 222 8 into 8. Okay, so if you will get it, you will get it as a 3136.8 kilonewton meter. Similarly, if you want to find out the bending moment at second floor, this one, so that would be M2, that would be F3 time 4. Okay, so that would be the F3, how much? That is a 22.8 into 4, so you will be getting 891. Is it okay? Any doubt? This is the our question. Any doubt in this question? If not, let us move a very simple question. We need to find out the shape function for this simply supported beam with the uniformly distributed load W. So in this you need to do nothing. You need to find out the your expression of the deflection in term of the ux, and you need to divide out about the u naught or the whatever the maximum of ux. Okay. So in this case, ux you can determine by using the uh, that force, that udl. Can you find out the displacement expression? You can calculate it by using d2y over dx square or m over ei. Okay, so mx, so mx you can calculate at the distance x as the reaction will be the wl by 2, wl by 2. So the reaction mx would be the wl by 2 into x minus wx square by 2. Okay, so if you put the value ai into d2y over dx square, mx is as your wl by 2x minus wx square by 2. So what you need to do, you need to do the derivative. So that is the ei into dy over dx, that would become as a w by 2 into x square by 2 minus wx cube by 6 plus y constant c1. Then again do the derivative to find out the y. So that would be the wl by 2 into x cube by 6 minus wx4 by 24 into c1x plus c2. So now we need to apply a boundary condition. So can you tell me what are those boundary conditions for this?
At x equal to 0, y equal to 0. At x equal to L, y equal to 0.
So we have these boundary condition. Okay,
Okay.
or another we can use this as a 8 y is equal to l by 2, theta is equal to l by 2 would be 0. That would be the another case also. That also you can do that. Okay.
Okay.
So first, let it x is equal to L by 2, my theta is 0, or my dy dx. Okay. So if I apply for this one, ei dy over dx is equal to wl by 2 into L by 2 square by 2 minus W into L by 2 cube divided by 6 plus C1 is equal to 0. So from this, I will get C1 as a minus WL cube by 24. Okay. Now it x is equal to 0, y is equal to 0. So that would be the 0, 0. So in the this term, ei into y. So if I will put WL by 2, 8x, it would be 0, minus it will be 0, plus C1 times 0 plus C2 is equal to 0. That means C2 is equal to 0. So my final equation, yx, y or your ux is coming at wl by 2 into x cube by 6 minus wx4 by 24 minus wl by cube by 24x divided by ei. And u maximum, you can find out the u maximum by putting the x is equal to L by 2 in that equation. You can find out the u maximum. So as we know, u maximum when the applied load is this one, so that comes out to be minus 5 by 384 into wl power 4 by ei. So our safe function would be the ux by u maximum. So I can put this into this value. So my final safe function, if you put this value, that will coming out to be, after rearranging the terms, you can rearrange by yourself. So that is coming out to be 16 by 5 x by L plus x4 by L4 minus 2x cube by L cube. Is it okay? Any doubt? This was a very simple question. If you don't have any doubt, so let us move to a next question. So this is a very long question actually. So this I have two question. In this one question we have the tapered chimney. In the another question we have the flat chimney. So the flat you can do simply. If you will be able to do the tapered, the flat you can do, because time restraining. I it will take around half an hour to complete that question. I think. Let me think. If not, then we will cover that question also. So we have given a reinforced concrete chimney which has a 200-meter height, has a hollow cross section with outside diameter as a 16-meter at the base and the 8-meter at the top. The wall thickness is the 1 meter, uniform over the height. So wall thickness is the 1 meter. So using the approximation that the wall thickness is small compared to the radius. So T, obviously it is very small if you compare the radius 1 meter and the 16 meter. So the mass and the flexural height. So the mass and the flexural properties are computed from the gross area of the concrete. The chimney is assumed to be clamped at the base. It is considered as a fix at the base, and damping ratio is the 5%. The weight of the concrete is 2400 kilogram per meter cube. Elastic modulus is given as a 25,000 MPa. Assuming that the shape function as a 1 minus cos pi x by 2l is given to us, where L is the length of the chimney and X is measured from the base of the chimney. So we need to find out the quantities as a shear force, bending moment at the base and at the mid height, and the we need to find out top deflection due to the blast force varying linearly over the height from zero at the base to PT at the top. Okay, so that we need to do where the PT is given by the figure. So in this, this is a continuous system. So till now, up to the last question, we have done the like up to the fourth question, we have done the lumped mass system or the discrete mass. Now we are doing the continuous mass system. So first, we need to calculate the properties. So the radius at the bottom, r at bottom, how much? It is 16 by 2. It is 8 meter. Radius at the top, it would be the 8 by 2, it is the 4 meter. Okay, so we need to find out the r average, like we have the hollow. So the r average is this at the middle. Okay, so r average at the bottom, we can find out as the thickness is given to us as a 1 meter. So this is up to this is a 8 meter. So that would be the 8 minus 1 by 2. So that is a 7.5 meter. R average at the top, that was the 4 minus 1 by 2 is the 3.5 meter. So can we calculate the variation of the R? Like it is variation, it is 7.5 at that to 3.5 at the top. So R average variation, that you can do directly. How much difference it is extra? 4. So that will be varying as a 4x by L. Okay, so that would be the 7.5 minus 4x by L. Is there any doubt in this up to this? So now we need to find out the area mass. So area is given as a gross mass. They have told in the question that the mass and the flexural stiffness properties are computed from the gross area of the concrete. Okay, so ax for the mass, I need to calculate the volume or the area first. So area of chimney, ax, that will be the, if I will open it, if I open this whole as a r average, like if I open this circular as a circular, so it will become like a rectangle type, which has a this has a r average, and the thickness would be the 1 meter. So that is coming out to be, so that would be r that not r average, so that would be our r radius, so that is the parameter 2 pi r average. Your ax would be the 2 pi r average times the thickness. So that is a 2 pi r average is the 7.5 minus 4x by L into thickness is the 1 meter square. So mass, you can calculate mass per unit length. So that is the rho time ax would give you the kilogram per meter, the mass. So concrete density is the 2400. Okay, 2 pi 7.5 minus 4x by L. So further you can simplify this or keep it like that, kilogram per meter mx. So now can you tell me what is the I for this? If my thickness is very less compared to height or the radius, my I is given as for this one as a pi r average cube into t. How do we calculate this? As you know, for the hollow section, so here that would be the r. So for the hollow section, what is my I? There is pi into d outer power 4 minus d inner diameter power 4. Okay. So if I will put d outer was what was d outer was would be 2r average plus thickness, and d inner would be the 2r average minus thickness. So if you do that, substitute into this, then you will find out I is as a pi r cube average times t. Okay, so you can find out I in is equal to pi into 7.5 minus 4x by L cube times 1. So you can write it like that, pi, simple, that is a meter, like 1. So that will be the pi into 7.5 minus 4x by L cube meter 4. So now we need to find out the m equivalent, k equivalent. That is the one thing only now. So you have given your safe function psi x is given as a 1 minus cos pi x by 2l. Okay. So using that you can find out the m equivalent. M equivalent that would be 0 to L times the mass mx time psi x square into dx. Is it okay? Did you remember this formulation? So 0 L is a 200, mx is given as a 2400, 2 pi into 7.5 minus 4x by L, and it is given to 1 minus cos pi x by 2l square into dx. So put L is equal to 200 in this equation, or first you can do the integral and then put the L is equal to 200. So if you do that, you will find M equivalent is equal to 288,524 kilogram. Any doubt up to this point? After calculating the initial properties, then it is like a simple like we have done. Now we need to find out the K equivalent. So for this, you need to do 0 to L ei times psi double dash x square dx. Okay, so first we need to find out the psi double dash x. So that will be pi by 2l square into cos pi x by 2l. So if you put k equivalent in this 0 to 200, ei is given to as a e is given as a 25,000 into 10 raised to power 6 I we have calculated pi into 7.5 minus 4x by L cube, and that is your cos pi x by 2L square into pi by 2L power 4 into dx. So if you put this L and x, you will find out your stiffness as a 7882,897.9 Newton meter. So can you give me the frequency and the time period? Before that, let me find out the L equivalent also. So that is 0 to L mx psi x dx. So the mx 0 to 200, that is 2400 into 2 pi into 7.5 minus 4x by L into 1 minus cos pi x by 2L into dx. So if you do that, you will find out it as a 4978369.3 kilogram. Okay. So can you give me the omega n and Tn? You have the value of mass, stiffness. So give me the omega n and the Tn. Then we will come out to the load, part of the load, how the load is applied. So first we need to find out those things. So please provide me the omega and the Tn.
1.652 radian per second.
Okay, so omega n is the, this is the omega n na,
Yes, yes.
k by m. So that will be coming out to 1.65 radian per second. So similarly, time period we can calculate 2 pi by omega n. So that will coming out to be some 3.801 second. Okay. So now we need to come up with the force force part. So in the force part, they are saying that this is linearly varying with the height. Okay. So my pxt is given as a x by L time the pt p or the pt p. Okay. So this is varying with that pt. Is it okay? So for finding out the generalized p equivalent, that is 0 to L pxt times psi x dx. So that is 0 to 200. Pxt is x by L into pt, and shape function is the 1 minus cos pi x by 2L dx. So can you give me the p equivalent in term of the pt? Pt take the outside. Can you give me the P equivalent? So if you do the derivative, I am getting it as a 53.73 pt. Okay. So now I need to calculate the pt. So the response due to this we need to calculate. So the response like this is applied like that, and this is given to up to the 0.25. Okay. So and this is as a pt as a 60. So if TD is given me as a 0.25 second. So my TD by TN, if I will calculate, that is a 0.25 divided by the how much, that was 3.8. So that is coming out to be 0.065. So that is very very less than 0.25 second. Okay. So I can take this pulse as a area. So for this, how was my response? Z naught, that would be the I by m equivalent into omega n into pxt. Okay. So I is what, 1 by 2 into 60 into 0.25. M equivalent we have calculated 2885,244, and pxt was, what was that, 53.73 into 10 raised to power 3. Okay. So if you do this, I am getting my z naught as a 0.08449 meter, or you can say it as a 84.5 mm. So now we need to find out the deflection. For the deflection, how the deflection is given as a u naught is equal to psi into z naught. So shape function is given as a 1 minus cos pi x by 2l into z naught is your 0.08449 meter. So at the top, at x is equal to 200 meter, my u naught would be 1 minus cos, if I will put it into this, pi into 200 by 2 into 200 into this. So that will be the 1. So my u naught would be the 0 point, like simple 84.45, 84.5, not the 45, 84.5 mm deflected at the top. Now we need to determine the shear force. So for the shear force, as we have discussion, that was the m omega n square times z naught into psi x, either in terms of the a or either in terms of the z. So at mid height, vl by 2 will be fx dx from l by 2 to l, from 200 100 to 200. That would be the m is what, 2400, 2 pi into 7.5 minus 4x by l into omega is 1.65 square into say function z naught is how much? 0.08449 into 1 minus cos pi x by 2l into dx. Okay, so you need to integrate this. So after integration, you are getting the shear force at the mid height is you will be getting 937,502.7 Newton, or you can say 937.5 kilometer. Similarly, at the base, you need to do this from 0 to 200. Same thing, nothing you do not need to change. 24 2 pi 7.5 4x by L 1.65 square into 0.08449 into 1 minus cos pi x by 2L into 3x. So if you will do that, you will be getting V at the base 115, sorry, 1150701 Newton or 1150 kilonewton. So this is your shear force. Now come to the moment, bending moment. So to find out, let us suppose moment at the L by 2. So for this, we need to do from the L to L by 2. These formulation I think that has been discussed in the class, so I am not going into the detail. Fx into dx. So if you put 100 to 200 into x minus 100 into 2400 2 pi 7.5 minus 4x by 200 into 1.65 square into 0.08449 into 1 minus cos pi x by 2l into dx. So if you do that, you will find out this as a 524,986.30 Newton meter, or you can write it like this 52.5 mega Newton meter. Similarly, at the base, MB, you need to do it 0 to 200, and that will become L by 2 would be the will not be there. Okay, so that is the x into fx dx. So final you will get the it will be 161.5 mega Newton meter. Any doubt in this question? Anyone? Do you have any doubt? Anyone? Because that was a simple. And we have one more question that is the same, but in this only difference is that we do not have the blast loading. This is also the sort of example of the Chopra. You can go with that also. In this the straight like no variation in the radius. So in this I will write the procedure how, and the save function is also given to you. So in this you can find out like length is given to you as a 200 meter. Same question, nothing is difference, only that is the earthquake is applied
Actually, this question is already done in the lecture also.
is done in
Same,
the lecture. Then I
same question.
which one, previous or this one?
This one only.
Okay, then there is no need to the follow. So
Completely has done by sir.
the follow the Week 7. Which module?
Module,
3.
actually second module.
Module.
Uh, I don't know. Second module. Second module.
Okay. So that is okay. If you have any doubt, anything in the all the 6 7 questions, you can ask me here. That was very long question actually. That took around half an hour.
In the assignment,
Yes.
uh, question number is third question. They are asking equivalent static force at the first floor. For finding the equivalent static force, you need K value.
Which question?
Third question. Third question.
Okay. So in that the three-story frame subjected to ground motion, which is this and that. Okay. So what you required for this?
Actually, I didn't see completely, but I think we need a K value. That means stiffness of the columns.
No, you do not need that stiffness.
Okay, okay. Uh, then I have for a second question.
Like same thing we have discussed in this session. Like app, what was the or app? If you go through this,
Okay.
let me show you in this FSI.
Mm-hmm.
So is there any need of the stiffness?
Okay, okay. Understood.
So that's how you can solve it.
Yeah. And the second question. Uh, there for finding the equation of motion,
Yes,
we, in the jetty is applied at damping at the damping, right?
yes,
I have what I have done is that for here hinge is there at the left side.
yes,
I have taken the moments about hinge,
yes,
and I have developed two equations.
yes,
Right? Correct.
yes, yes.
There I have tried more. Like I didn't get that. Just I didn't get the answer even. Is there any hint for that? Is there correct?
Yeah, that is correct way. Like you, like there are many more ways you can find out. Like you can cut a rope at the
Yes.
level of damping. You can find out the R or some reaction force at that point. And in terms of the R, you have the equation of motion, equation for the like you take the moment about for the beam or the you can say the bar, and there is a R in terms of the R, you have the forces from the equilibrium from the pulley side, and then put the R value in that, you will find out your value. There is nothing.
Yes. Yes. I have done same like same.
So might be
Okay.
you are doing some calculation mistake, so you can go with that. But the procedure, whatever you following is that is correct.
Okay. Next thing, in the previous week, you said like the third one is like stress is wrong, right?
Yes, your calculation of the stress is wrong. I told you.
I have seen uh, again. I have seen there, but I didn't get that stress is m by z, right? What you are telling like it is not in the range, right?
Yes, stress is in the M by Z.
Yes. I have calculated again now only, but same thing
So
like
your
that.
maximum moment, how much maximum moment you are getting?
Maximum moment is 59.418.
Okay, 59.48. So let us
Yes.
suppose it is 59 or okay, 59.48. Okay,
Yes.
then what is the I that is given to you
Yeah.
174?
I is like I calculated like pi by 64, capital D power 4 minus small d power 4.
No, I is given to you question in the question form. Also, they have asked you to the whatever I is given to you consider. That only thing is that the external and the inner diameter is used for to calculate the bending stress.
Okay, then only we get right.
Yes, I you
But,
have to use the whatever given the 174.
yeah, but I have used this thing
No,
only.
if the I is given to you, then you have to use this. The outer diameter is given only for you to outer and inner diameter for the finding out the bending.
Why?
Yes, so that
Yeah,
y is used to be whether like it is given to you 168.3. So if you divide it by 2, then you will get the y by 2 extreme fiber distance, and the I is the 174 is given to you. Then you can calculate the sigma.
yeah, yes. I
The
think
solution I think uploaded, so you can follow the solution.
yes, uploaded okay, but it's procedurally it is correct, right? That's why I'm asking just for
No,
clarity.
yes, I is given to you. That's why only the inner and outer is given to you for the stress.
Okay, okay. No, it is. I think it is no way to give marks, right?
Yeah, only thing you can get in the first and second because that range was shorter. So I you as you mentioned the form, so the NPTEL team will take care of it.
Okay, okay. Thank you.
So anyone has any doubt, or should we conclude the session? If you don't have any doubt, so you can leave so that I will conclude the meeting. Thank you for being in the session.